Hello, I hope everyone's having a good day. Today we are going to add and subtract fractions with like denominators. And just a reminder, our numerator of a fraction is our top number and a denominator is our bottom number. So we're going to start with like denominators and then we'll get into fractions with unlike denominators. So for example, if we had a fraction 1/4, that'd mean we have one piece out of 4 pieces that the object was cut into. We can add two fractions with like denominators by recognizing that the denominators mean that both fractions were cut into the same size pieces. So if I had 2 pizzas and I'm adding the pieces together from leftover from our pizza party, I can add my pieces if they were cut into the same size. So we'll start with 1/16 plus 4/16. If I had something cut into 16 pieces, maybe I've got a bar cut into 16 pieces. I've got 1/16, and I'm going to add that to 4/16. And then in our addition here, 1 plus 4, we get 1, 2, 3, 4, 5/16. When we add fractions, our denominator will stay the same when we add across, and then we'll just add our numerators. Let's do another one. We had 7/12 plus 1/12. We'll add our numerators straight across, so 7 plus 1 to get 8, and then our 12 just comes over, so we get 8/12. This is a fraction we can simplify. Both our numerator and our denominator are even numbers, so we can take 8/12. Since they're both even, we could divide by 2. 8 divided by 2 is 4, and 12 divided by 2 is 6. And looking at 4/6, we could actually simplify some more. So we can actually divide both by 2 again. 4 divided by 2 is 2, and then 6 divided by 2 is 3. So our 8/12 simplifies into 2/3. And I want to show that with the manipulatives real quick. Got 1, 2, 3, 4, 5, 6, 7, 8/12. Oh, that's 16ths. Hold up. There's 12ths. Okay, 4/12, 5/12, 6, 7, 8/12. And then comparing that to 2/3, we got 1/3 and then 2/3. We can see our 8/12 is the same size as 2/3 on our fraction pieces. All right, so that was adding fractions when our denominators are same. What about when we're subtracting fractions with the same denominator? So when we subtract with the same denominator, we actually pretty much do the same thing. If I had 7/16 minus 5/16, I'm going to show with the manipulatives. So I've got my 16ths here. 5, 6, 7. I had 7/16, and then I need to take away 5/16, so I'll take 5/16 away from this. 1, 2, 3, 4, 5. I'm left with 2/16, so I would write that as 2/16. Or if I want to just do arithmetic, don't think about the manipulatives, I would do 7 minus 5 to get 2, and then my denominator comes straight across. And then when I have 2/16, I can actually simplify this down because 2 and 16 are divisible by 2. 2 divided by 2 leaves us with 1, and 16 divided by 2 leaves us with 8. And then if I compare my 2/16 to 1/8, it should look the same. So when I add or subtract with like denominators, I'm going to add or subtract my numerator and bring that straight across, and then my denominator will just carry over and stay the same. If I have unlike denominators, I need to find a common denominator before I can add or subtract. So for example, if I had 3/8 plus 1/4, 3/8, and then add 1/4 to that. Looking at these are different sized pieces. I can't just count 1, 2, 3, 4, because these aren't fourths, and this is a fourth. And I can't say, well, okay, I've got 4/8 because these are eighths and that's a fourth. They're different. They look different. So I need to find a common denominator. And to find a common denominator, I need to find something that both denominators can multiply to get. So looking at 4 and 8, I'm going to look for multiples of both 4 and 8. 4 times 1 is 4, and then 4 times 2 is actually 8. And a number is always a multiple of itself because 8 times 1 would be 8. So our common denominator is going to be 8. Now that we know that, what we need to do is convert our fractions into something over 8. So 3/8 is already over 8, so we don't have to change it at all. But our 1/4, we will need to change over to something over 8. And we established a minute ago that 4 times 2 is 8. So to change our 4 into an 8, we'll have to multiply that by 2. 4 times 2 is 8. If we do something to the top of or bottom of our fraction, we need to do it to the top as well. So we'll do 1 times 2 to get 2. And 1/4 turns into 2/8. Now that we have both our fractions over 8, we'll rewrite our problem. And our new problem is 3/8 plus 2/8. Now that we have same denominators, we can add these because I've got 1, 2, 3/8, and then add that to 2 more 8s. Now I can count, okay, I've got 1, 2, 3, 4, 5 8s. Or I could just add straight across 3 plus 2 is 5, and then our 8 comes over. So sometimes our like denominator can be one of the numbers in our fractions, or sometimes our like denominator might not be one of our numbers. So let's do one with subtraction. I've got 1/2 minus 1/3. And if I put my pieces out, well, with 1/2, I can't pull anything out like I did before. And so if I needed to pull something out, it'd be the size of this 1/3, but I can't pull that out of 1/2. 1/2's just one big piece. So I need to convert to like denominators, which will make it so that I can pull something out. When I look at these two fractions, 2 can't multiply to get 3, and 3 can't multiply to get 2, so I do need to find a denominator that both of these can share. So I'll find some multiples of 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And we'll go ahead and do 2 times 4 to get 8. We'll do the same thing with 3. 3 times 1 is 3. 3 times 2 is 6. And then 3 times 3 is 9. And if we look here, we've actually got a common factor, or common multiple. We've got 6. Both numbers can multiply to get 6. If you're looking for a common denominator, you can just use the multiplying the two denominators by each other. So you could do 2 times 3 to get a common denominator, or whatever your two denominators are. I will say, if you do that every time, you might be working with bigger numbers than you have to. So it's a quick way to get through, but it might make you have to simplify more. So if you find the multiples, you can actually work with smaller numbers. So our common denominator is 6. Both our fractions need to turn into something over 6. So 1/2 to turn into something over 6, I've got to do 2 times 3 to get 6. And then I'll multiply my numerator by the same thing. So 1 times 3 to get 3. My 1/2 turns into 3/6. Then I'll do the same thing with my 1/3. 3 times 2 gets me 6. So then I have to multiply my numerator by the same thing, 1 times 2, to get me 2. So my 1/3 turns into 2/6. My new problem, when I rewrite it, is going to be 3/6 minus 2/6. Now that I have everything in 6, I can subtract using my manipulatives. So I've got 1, 2, 3/6 here. I can just pull out 2 of those, and I'm left with 1/6. Or I can subtract straight across. 3 minus 2 leaves me with 1. And then my 6 comes over. For this one, there's no simplifying to do. We're as simple as we can get because our numerator is a prime number and our numerator is 1. So we can't simplify. All right, if anyone has any more questions about fractions, just feel free to reach out. That's all I've got to go over with y'all today. Have a great week.